because you are very, very much grateful and big profile in our technical work. I know very well about your research and knowledge, sir. Tilshia sir also told me about your research and contribution across the globe. You are the innovator of the many things. I know, sir, very much happy to present and interact with you. It's a very great honor, sir, to me.
Yeah,
In
yeah.
near
Thank,
future, we are happy to collaborate with you, sir. Kindly
sure.
accept me.
Yeah, thank you. Thank you very much for your kind words, and definitely we will collaborate. And as much your area of research, and definitely we can collaborate with some joint publications and research and some innovative ideas and converting these ideas into the reality. So, can I share my screen or?
Yes, yes, sir. Please wait, sir. Audience our pipeline. You know, sir,
Okay,
I am the innovator of the IPv16, Internet Protocol
okay,
version 16.
okay.
I'm newly introduced on technical world. After
Let,
IPv6 and IPv4, I am the
mhm.
innovator of the IPv16. Already
Great,
tells
great.
the
Yeah, yeah,
information.
great.
In the way, I'm trying to interact with you and
Mhm.
some research collaboration with you, sir, with your Cardiff Metropolitan University. Also looking for that.
Yeah,
Kindly
yeah, yeah.
help me in this regard.
Sure, 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 sure. We always welcome all the new researcher and great researcher contributors, definitely. And my area of interest is also IoT, connected vehicles, cyber
Yes,
physical systems, cyber security, and currently I'm the head of cyber security of autonomous systems. So we can collaborate and we can execute the new ideas, definitely. No problem at all.
in the way we have strong team in our in this area, sir. We
Mm-hmm.
will touch with you later, and I will
Sure,
chat with you. And
sure.
kindly accept me, sir.
Yeah,
Uh,
yes, yes, sure, sure. Sure, sure, sure.
we are creating wonders in near future, sir.
Definitely, definitely,
Thank you,
definitely.
sir.
Great.
Can we start
Great.
the session, sir?
Yeah, 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 sure.
Please wait. Please wait within 5 minutes, sir. All
Okay,
of the
okay, no problem.
participation may be pipeline.
Okay, okay, no
We
worries,
are
no
great
worries.
honor to you, sir.
Okay, no worries, no worries.
Thank you, sir. Start చేసి
Sir Rajkumar sir, can we start the session, sir?
Rajkumar sir, can
Yeah,
you hear me?
yeah. We can hear you. I can hear you.
Sir, start the session.
Well, a very
Okay.
good morning once again. I would like to invite our keynote speaker, Dr.Rajkumar Singh Rathore, who is going to deliver a session on next generation intelligence security solutions for connected and autonomous vehicles. Before we start this session, I'd like to introduce Rajkumar sir profile. So it gives me immense pleasure and privilege to read the Rajkumar sir Rathore profile. Dr. Rajkumar Singh Rathore is working as a Program Director for MSc Information Technology Management and Technology Project Management in Department of Computer Science at Cardiff Metropolitan University's School of Technologies, United Kingdom. He has gained doctorate degree, dual master's degrees, and bachelor degree all in computer science and engineering discipline. Dr. Rathore is a scholar throughout his career. He is a fellow of HEA UK. He has several years of rich experience in quality of teaching, learning, and research excellence. His research works were fully supported by Nottingham Trent University, United Kingdom, and Manchester Metropolitan University, United Kingdom. He has co-authored several textbooks for BSc and MSc students on different modules of computer science. He has expertise in research-informed teaching methods and has been awarded as best teacher many times during his career. He is the member of various prestigious international organizations in the field of computer science. He is a reviewer for several reputed peer-reviewed international journals and conferences. He has served as a technical program committee chair and chaired sessions in reputed international conference. Dr. Rathore has an outstanding R&D background and currently is working on funded project for security of in-vehicle communication based on machine learning. His research expertise are as follows: Internet of Things, cyber physical systems, cyber security and privacy, connected and autonomous vehicles, intelligent networking of drones, use case of deep learning. So it gives me once again immense pleasure to invite our keynote speaker, Rajkumar Singh sir. Over to you, sir.
Thank you very much for your kind words. I'm just going to start my session.
Sir, your voice is not audible, sir. Speak loudly, sir.
Can you
Voice
hear
is
me?
low, sir. Sorry to
Can you hear me now?
little bit, sir. Please speak
Uh,
loudly.
uh, Once again,
Please increase your volume, sir. Right now you are mute, sir.
now you can hear me.
Yes, sir. Yes, sir.
Okay. Thank you. Can you see my screen?
Yes, sir. We can see you. Did you
Yeah.
share anything, sir?
Yeah. I
Right
have.
now, okay, sir.
Yeah. Okay. Thank you. So once again, thank you very much for inviting me for this conference. I'm just going to share my experience. Currently, we are working on that particular scenario of connected and autonomous vehicles and the next generation intelligent security solutions. So I would like to share few of the new intelligent work about this, because we as a team are working currently on providing the intelligent security solutions for the manufacturer right now. So this is the somehow the reflection of the current work which is going on, and some of the work I am also the part of that particular environment for providing security solutions for the connected and autonomous vehicle. So before going in the more detailed, I would like to highlight the outlines of the presentations. So we will start from the introduction part, and then we will go move towards the key security concerns for the CAVs, and then the threat landscape, next generation security solutions, and finally the futuristic approach for this particular area. So I will cover the important aspects basically, and try to give you the information about this, because I know that all of you are doing great research and you are aware of all these facts and figures. So I would like to provide only the key information about this, so that we can discuss this in much more detail later on. So first, I would like to highlight the uh, key terms. Generally, all the researchers are aware of this particular factor: cyber security and the cyber attacks and the connected and autonomous vehicle. But I would like to highlight these facts once again. So cyber security, uh, each and everybody know about the how to individuals and the organizations basically reduce the cyber attacks. So this is the uh, backbone of this particular area, the cyber security of connected and autonomous vehicles. So what is the cyber security? How we can protect our environment, organization, from the unauthorized access, from the unauthorized gain. This is the complete scenario of how to make robust our entire system. This is the main aim of this particular cybersecurity aspects. So this is a cybersecurity, a fundamental definition of the cybersecurity and the cyber attacks, how to gain, or you can say, unauthorized access to computers in the general sense, or we can say in any environment, and particularly we are focusing on the connected and autonomous vehicle. So now, what is the connected and autonomous vehicle? So you can see here that there are two different keywords: connected and autonomous vehicle. Generally we are confused with the CAVs are the single term, but there are two aspects: connected and the autonomous features. So all the countries are currently working on that particular scenario for the connected and autonomous vehicle, and there is a particular manufacturer, Tesla, is very advanced in doing different types of research for this particular area, which is producing, or you can say manufacturing, their different connected and autonomous vehicle efficiently currently in the entire world. So I would like to highlight the two important aspects. One is the autonomous feature, and second one is the connected feature. As you are aware, the autonomous means the system is freely can navigate in the entire environment, and with respect to the, if we are going to talk about the uh, vehicle scenario, then there is a little bit interfere from the driver side. The system is more intelligent. So as we can say that the autonomous feature is somehow is also linked with the intelligence. And we know, if we are going to provide the intelligence, then definitely we require the AI and machine learning features. So this is the entire environment of the autonomous feature. So in this feature, we require the little bit in interference from the uh, driver. So all the maneuvers, all the decision making capabilities, the in-house the computing system can automatically take the decisions based on the particular scenario. And the connected feature is totally different. The connected feature is only linked with how we can communicate with the external world or the internally. If we are going to have the reference from the vehicles, then the connectivity basically uh, in vehicle and vehicle to infrastructure, V2X, and vehicle to vehicle and vehicle to roadside units. So how we can communicate effectively, this is the main you can say scenario of the connected vehicles. So connected vehicles are totally different from the autonomous vehicle. Vehicle can be connected and autonomous both, but these two terms are totally different. All the vehicles are basically which are in the autonomous sense must be in the connected sense, but all the connected vehicles are not necessary where we the autonomous. So these are the complete scenario, or you can say the backbone of the connected and autonomous vehicle. Now we are moving towards the next phase of the need for the connected and autonomous vehicle cyber security framework. So the aim of this particular slide is to just discuss the main part of how we can think the screen is not clear. You hear me?
Sir, your screen
Can
is,
you hear me?
yes, sir, I can hear, we can hear you.
Yes, sir.
I
Yes,
think
sir.
there is a problem with the communication. I think
No, sir. No, sir.
working.
Yes, sir.
I think there is a problem with here. I think it is not working.
Once again, please share, sir.
Yeah, yeah. I'm once again sharing. Sorry for the interference.
Please share your screen, sir.
Yeah, yeah. I'm once again sharing. Sorry for the inconvenience.
Okay, sir. Some technical issue, sir.
Yeah, yeah.
No worry.
Maybe.
Please.
Yeah, yeah. I'm just once again sharing. Google Meet is somehow actually creating the problems. So we prefer actually for the Teams meeting rather than on the Google Meet for the long presentations.
Yes, sir. Please share your screen, sir.
Yeah, yeah. I'm just sharing. Can you see my screen right now? Can you see my screen?
Yes, sir.
Sir.
Okay, okay. So I'm just moving towards the yeah. So you can see this is the basically the interconnection between the physical world and the digital world. So how the this particular area comes, the main aim of this slide is to let you aware where the connected and autonomous vehicle scenario comes between the physical world and the digital world. So this is the intersection basically between the physical world and the digital world, the complete entire CAV cybersecurity framework. Okay. So now I am just moving towards the cybersecurity innovation models in the connected and autonomous vehicle ecosystem. So you can see there are only three important pillars for this connected and autonomous vehicle ecosystems. That is the cybersecurity, technology, and the manufacturers. So these are the important pillars in the connected and autonomous vehicle ecosystem. Now, this is a very good example of the complete scenario for the connected and autonomous vehicle. Here you can see there are different types of access points, roadside units, and all the smart countries, or you can say smart cities, are utilizing the different types of models for effectively utilizing the concepts of connected and autonomous vehicles. But as we are growing in terms of advanced technological environment, there is a particular, or you can say, we are opening the door for the different types of attack surfaces for the new attacks. So as we are moving towards the providing the more facility, more functionality, or you can say making the vehicle more efficient in terms of autonomous decision makings and providing the more functionality to the end user, we are also opening the door for the new attacks, and we are creating the new attack surfaces. So this is the entire environment, how we can utilize the concept of uh, different types of new features, connectivity, enhancing the more connectivity with the roadside unit and different components. So this is the particular scenario from my one of my paper recently published in the journal. So now I am moving to the main part. What are the key security concerns for the connected and autonomous vehicles? So the first concern is very important, the data privacy. How we can protect the data, because there are lots of data communication among the different entities, from vehicle to the roadside unit, vehicle to the entire infrastructure outside. So the main concern is to how to prevent the unauthorized access or misuse. So this is the main concern for the connected and autonomous vehicle. And the second one is the cyber security. Yes, of course, how we can secure our intelligent vehicle, which is, you can say, we can we can we can tell the our intelligent vehicle as a this complete environment as a cyber physical system also. There are lots of articles you can see, and they are converting the entire scenario, and they are telling the entire scenario as a, this is also one of the great example of cyber physical system. So the entire connected and autonomous vehicle and the communication and this entire environment can be treated as a one of the example of cyber physical system. And the third part is also very important, software vulnerabilities. Yes, definitely, if we are going to have the more functionality and we are creating the more we are providing more functionality, so the different types of softwares and their updations, and how we can upgrade the firmware of the different components. So there is a problem of vulnerability also. The intruders can hack the system, they can insert the malware inside the main computing units of the vehicles, and they can hijack the entire vehicle. So software vulnerabilities and the communication securities, vehicle to infrastructure, vehicle to roadside unit, and so on. How can we secure the communication channels? And this is also over the air updates is also somehow related to the software vulnerabilities, because the different components require the upgrade time to time. Software upgrade versions are going to be upgraded automatically. So we need to make sure the entire channel must be secure enough in order to provide the security to the entire infrastructure. And these tiny components play a major role in making the system more robust in terms of cyber security environment. And then the supply chain security, this is a new concept basically. So now we should be aware that the different manufacturer, or you can say OEMs, original equipment manufacturers, is also the part of that particular environment for assisting us to make the system more robust in terms of security features. And the legal and regulatory challenges is, yes, of course, because these types of vehicles connected as well as autonomous vehicles having the different scenario as compared to smart vehicle. The smart vehicles may have the connectivity, but that particular vehicle may not have the autonomous feature. To make the more robust in terms of autonomous features, there are certain guidelines, there are certain regulations in different countries. So this is also the regulatory challenges for successful execution of that particular connected and autonomous vehicle scenarios. And then again, the last one, which is also very crucial for the perception, public perception, how the public perceive about the security and safety of the entire society with respect to the connected and autonomous vehicle scenarios. So these are the key security concerns for the connected and autonomous vehicle scenario. So now I'm just moving towards the threat landscape. So in this diagram, it is very clear. You can see here how the attackers can attack your connected as well as autonomous vehicles. So here there are two scenarios: cooperative scenarios in which you can see there are platoon of vehicles, and the individual CAVs. With the help of individual CAVs, you can see here how the particular uh, attacker can attack the entire network of the particular vehicle. And there are lots of channels you can see here with the help of internet, and then information technology services, and then the roadside unit and the access points AP. And they can also these are basically the opening doors, or you can say there are basically the attack surfaces for the attackers to just attack the vehicle. So this is the particular threat landscape to provide the glimpse of how we can secure our vehicle. If we are going to secure our vehicles in terms of individual identity, then we should focus on the individual ECUs, electronic control units, so that we can just thwart the attack of the particular attacker and make our vehicle more secure, robust. And in terms of cooperative CAVs, we should be aware of that there are access points also that can create the problems for our vehicles. And so we can have some security measures in terms of whenever there are attacker try to interfere in that particular scenario. So the system must be intelligent enough and must be robust, and the framework must have the capabilities to identify the particular attack and make the actions accordingly. So this is the threat landscape, and these are the basically possible, you can say, doors which the attacker can utilize in order to create, or you can say take the advantages or unauthorized access to your vehicle. So TPMS, tire pressure monitoring system, each and every smart vehicle is having this feature, but this feature is also opening the door for the attacker in terms of eavesdropping, packet spoofing, and the vehicle tracking. And the smart vehicle nowadays is also having the lidar. So this is also opening the door for the spoofing, jamming, and saturated with noise. And cameras also can be utilized by the hackers. And definitely this is the canvas is basically uh, is the we have the complete scenario of the canvas. But as the technology advances in terms of TPMS, LiDAR, and cameras, more ECUs, so we are also opening the door for the new attacks. For the uh, uh, we are basically providing the attack surfaces, new attack surfaces. So this is the complete scenario. Now, uh, next generation intelligent security solutions for the connected and autonomous vehicle. This is our main aim to discuss. Till now we have discussed about the entire scenario, how we can communicate, how we can effectively communicate with the connected and autonomous vehicle, advanced connected and autonomous vehicles, what are the possible attack surfaces. Now you can see here the next generation intelligent security solutions must be more secure in terms of providing the more security in the communications and the intrusion detection and prevention schemes. I will discuss these all the seven factors one by one uh, in providing the more advanced information for all these scenarios. So basically, intelligent security solutions are covering all these dimensions, but in a different way. Till now, we are also working on the secure communication, but how to make the communication more robust? Either by advanced encryption, because currently also all the manufacturer automotive industries are having the feature of encryption and the proper authentication protocols. But we have to do much more advanced. We have to inculcate, we have to incorporate the more advanced features in order to make the system more robust. Because as the technology advances, we are also opening the doors for the new attacks and scenarios. So these are the basically seven dimensions, and in those particular dimensions, still we are working. And what are the new advancement in terms of security aspects. We will discuss one to one. So now I'm going to give you the brief introduction about all these seven uh, uh, you can say areas. Basically, secure communication basically is entire to is the main dependency on advanced encryption and authentication protocols, and idps systems basically utilizing the intrusion detection and prevention systems. And this particular second point is utilizing the intelligent algorithms. So ai and machine learning is playing a very important role in terms of second part, which is the intrusion detection and prevention system. And the third one is again the privacy protections. So here again we are having the secure data storage, cloud computing, as computing, and how we can utilize the effective new algorithms, intelligent algorithms, in order to provide the protection again, or you can say enhance the security levels for the privacy and the software integrity. Again, here over the air, how we can upgrade the system without compromising the secure level, or you can say without skipping the different security layers of the entire infrastructure. And then the physical security, yes, we can physical security is the totally different terms, because the hacker has to deal with the your entire you can say infrastructure physically. So this is the entire different things in terms of alarm and different types of security features. For example, rfid cards, smart cards, and your fingerprint scanners are also there in the new next generation cars of different types of manufacturers. And the advanced safety features, for example, the lidars and radars, and the how we can accurate navigate, and how we can effectively uh, make the system more more safer in terms of obstacle in detections and all. And the incident response and recovery, this is a very important point. After identifying the particular attack, what are the prompt response we can provide in order to just secure the entire environment. So this is the most important final point. So these are the main dimensions for next generation intelligent security solutions for the CAVs. Of course, these are we are currently working, and all the manufacturers are providing all these dimensions right now. But the mechanism is totally changing nowadays for making the system more robust in terms of more functionality, in terms of having the more power for handling the new attacks, how we can mitigate the different attacks, how we can encounter the uh, how we can counter the different attacks and different new mechanisms, or reduce the chances of hacking our intelligent vehicle. So this is the seven dimensions. So now I am just moving towards the uh, first one, how we can provide the advanced encryption and authentication protocols. So here you can see here, now in most of the cases for the advanced technological environment, the advanced encryption and authentication protocols we are utilizing. So uh, we are moving towards from the public key infrastructure scenarios to quantum resistance cryptography, homomorphic encryption. Nowadays you can see this is a very good important example of homomorphic encryption. Here we need not to just decrypt the entire communication in order to process the data. We can directly process the data. This is the main advantage of the homomorphic encryption. So in order to process the data, we need not to require to decrypt the entire particular data. We can directly process the data without the decryption. So this is the very important, one of the important encryption mechanism, homomorphic encryption mechanism for the connected and autonomous vehicles. And the next one is the ABE, based on the attribute uh, encryption mechanism. So attribute based decision making capabilities, we can say. And the second last is the lightweight crypto algorithms, because the entire connected and autonomous vehicles is having the main problem of limited computing processing capabilities. Because even the Tesla is having the very good functionality, but still if we are going to implement some higher level algorithms, so that they require the more computing resources. So there is a guidelines for having minimum requirement for the particular computing resources in order to make the system more robust, more fast, more responsive. If we are putting more computing parts or heavy computing parts, the system may be slow. So it will create the problem for the safety and security of, again, for the driver and the entire society. So we should focus on the lightweight crypto algorithms in order to make the system more robust and more fast. The last one is a very important part, or you can say nowadays we are focusing on the security aspects. We are also using the blockchain and the distributed laser technologies. This is the very good area in order to provide the protections for the latest generation of connected and autonomous vehicles. So these are the scenarios of the advanced encryption. Of course, there are various types of mechanisms are currently also going on, but there is always a scope of the new algorithms and new upgradation in terms of more secure features, or you can say more making the system more robust. So the researchers are also working on these particular directions. So this is the complete scenario of advanced encryption and authentication protocols. So this is basically belonging to the first part, how we can make the system more secure communications. So we require the authentication, advanced encryption, as well as authentication protocols. Now the second one is the IDPS. As we have discussed, that this particular part require the extensive utilization of machine learning algorithms. So basically, there are three dimensions of this particular area. The first one is the real-time monitoring of the vehicle network. This is the very, you can say, challenging task. The real-time monitoring of the vehicle network, because it requires the lots of resources, the cloud computing resources, where the data can communicate, where where your entire activities can be stored as a particular identity of the vehicle. And the second one is the behavioral based anomaly detections. Again, we require the new hybrid models, efficient hybrid models, in terms of making the more classifications based on the behavior. So again, this complete, we can say, the IDPS system is currently utilizing the extensive use of new algorithms, new hybrid models, which is based on deep learnings and intelligent algorithms. In the simple sense, we can say the intelligent algorithms. So this is the second part, and this is the particular section, we can say, the software vulnerabilities. This is basically governing the part of because the different components are the connected and autonomous vehicle is currently having the different important components. So they require the upgradation from time to time from the original manufacturers. So how we can secure this particular communication channel, so that we can have the devices which can upgrade their firmware effectively without compromising the security features. So again, we require some cryptographic validations and communication channels, and the automotive industries are very much focusing on securing the entire infrastructure in this, and this is also one of the possible ground for the hackers to create the to access the unauthorized access, or you can say to insert the malware into the original equipment. And now, this is also the one of the very important part, multi-factor authentication. So now the automotive industry is moving towards the multiple factors for the authentication rather than on the single factors. What is the main concept of multi-factor authentication? Multi-factor authentication basically is depending on different types of new facilities for the authentications. For example, in you can use your biometric fingerprint with the help of other smart card features also to gain access to your smart vehicles rather than on only the your key. With the help of new features, for example the biometric, or you can say smart contract, or you can say your different new devices, in order to provide the authentication that you are the genuine owner of your vehicle, or you can say to reduce the chances of the different attackers to just hijack your vehicles. So this is also the multi-factor authentication is also one of the important part of the new generation security solutions for the connected and autonomous vehicles. So the new you can say next generation security solutions also incorporating these types of different components for making the system more robust. So now this is also the risk based security monitoring. Again, this model is also totally utilizing the concept of AI and machine learning basically in order to provide the more security, but the three important part you can see here: the continuous assessment. The continuous assessment, whenever you require the continuous assessment, so you require the heavy you can say transactions, or you can say heavy communications between your vehicles and the outside world. So again, there is a case of more security, we require more security, but uh, risk based security monitoring, this particular area require the continuous assessment of your vehicle security posture. And the second one is the main is also very good you can say dimension for the proactive identification of potential security issues, and for that also you require the continuous observations of your vehicle, how your vehicle is communicating with the outside world. And this complete scenario of risk based security monitoring basically again utilizing the concept of AI algorithms in order to make the system more intelligent, because these types of, if you are going to monitor your vehicle effectively, you require some intelligent algorithms. So right now different types of hybrid models are utilized in order to make the system more robust. So this is also one of the dimension. So now what are the different trends, or you can say different futuristic approach right now is in the development phase, or you can say few trials have been conducted, but still there is not the single solution is available which is more robust. Yes, as the technology advances, new solutions are also advanced enough to just make the system more robust. But we can't say that there is a single particular solution available to make the system efficient in terms of all dimensions. Definitely there are lots of development in terms of security features, but there is always a scope of further improvement. So the first one you can see here is the main aspect, the AI driven security measures. How we can effectively utilize the artificial intelligence in order to make the entire infrastructure more intelligent. If the system is more intelligent, then definitely a system can mitigate the effect of attacks, different types of attacks. And the second one is the vehicle behavior monitoring. Yes, of course, this is also the next challenge, futuristic approach, how we can effectively monitor the behavior of the smart vehicles from the normal to the attack vehicles, and software and hardware security. Yes, this is also the challenging task, and the work is still going on. And the 5G and the edge computing, uh, because the new technology advances with the new attack surfaces. So these are the potential research areas for the next wave of intelligent security solutions. The security solutions is also uh, uh, providing all the support. But these are the possible dimension. You can see here, multi-factor authentications is also a very prevailing feature right now. But still, there is scope of more robust model for the next generations. So data security and privacy regulations, yes, of course. And then the final one is the collaborative security framework. This is one of the most important part, because not the single framework is available to provide the complete security for all the connected and autonomous vehicle scenarios. So we require some collaborative security framework in order to make the system more robust. So this is the complete scenario of the futuristic trends for the intelligent security solutions. So AI-driven security measures, yes, of course, they are utilizing the artificial intelligence, machine learnings for the providing the security features, making the system more intelligent. And for behavior monitoring, yes, again, we are utilizing the different intelligent algorithms to just find out the different ways of how we can make the how we can monitor the vehicles behavior, security and hardware security. And for this we require the cryptographic algorithms, authentication protocols, advanced encryption and authentication protocols, and 5G and edge computing. Yes, for the low latency and high speed networks and distributed processing capacities. So we have to utilize different new features in order to just increase the overall security. And multi-factor authentication we have already discussed, and data security and privacy regulations, and this is the collaborative security framework. So in the essence, or you can say in the conclusion, we can make one remark that the AI and machine learning is playing a very major role in providing the more security to the entire infrastructure for the connected and autonomous vehicles. And currently research is focusing much more on just hybrid models, and checking the efficiency of different types of models, because these are the intelligent algorithms is also playing a major role in the overall enhancing the performance, as well as providing the next level of security features, monitoring the behavior of your vehicles effectively for the new advanced connected and autonomous vehicles. So this is all about from my presentation for particular connected and autonomous vehicle scenarios. So if you have any questions, concerns, please, I am very happy to provide you the uh, inputs from my side. So currently we are actually working on the particular project for security of in-vehicle communications with the help of machine learning models. So we are also working on some hybrid modeling in order to provide the more security aspects for the in-vehicle communications rather than the vehicle to infrastructure, because you have to select the one particular line either on the in-vehicle communications or the vehicle to external world. So currently we are working on securing the entire infrastructure for the in-vehicle communications. So if you have any concern and any queries, then please let me know. Yes.
request the participants can ask any queries. You can drop a message in the chat box also. Well, sir, shall we wind up the session?
Yeah, please.
Yeah.
No worries.
Yeah, thank you. Sincere thanks for your time and your exceptional and intelligent vehicles, advanced encryption, cybersecurity topics, sir. So your session is very engaging and communicating way, which makes a significant impression to all the participants. Your expertise and enthusiasm were contagious, and everyone was mesmerized by your words. We hope to honor the welcome you back to our event stage sometime soon. We really appreciate your delivery of this session, sir. Thank you. Thanks to you once again, sir.
Thank you very much, and best wishes to all the participants. And I hope that your research will contribute a great impact on the entire community. And if you want to just communicate with with me, you can drop the mail. My email ID. I will send my email ID, and the organizers is also having my entire information. So you can reach out to me. I welcome you all in that particular directions. My area of expertise is IoT and connected autonomous vehicles, intelligent drone networking, and so once again, thank you very much for inviting me, and best wishes from my side for the successful of your international conference. Have
Thank you,
a
Rajesh.
nice day. Have a nice day.
Thank you,
Bye.
sir.
Okay.
Thank you,
Bye.
sir.
Bye.
Thank you, sir. Dear participants, thanks for your active participation for this keynote session, and we would like to catch you again the next session, which will be held on at 11 o'clock. At 1 o'clock. I request to be present 10 minutes earlier, 12:50 p.m., so that we can avoid any technical issues. And meanwhile, not only participating, that you better to utilize the resources knowledge. You can just raise your queries so that you'll get fruitful answers that will be really helpful to your research. Right, that's all for today's session. For this session, we'll catch you again on 1 o'clock. We'll share the feedback link, sir. We are recording of the participants' attendance. Moreover, we are going to share the feedback link for the next session. Thank you. Thank you once again. We'll catch you again at 12:50 p.m. Again, thank you.